All right, part two on light. So why did I mention the LL pseudotensor? Because many years ago, these two guys sat down and decided to calculate the gravitational waves coming from two black holes colliding. We see them, we measure them, we're trying to figure out what they are, how they work. And this one guy, these two guys had this idea that it's angular momentum, conservation of angular momentum, which is what I've been talking about. All right, so what happens is they sat down to calculate, but they had to do it for a flat space-time. Space-time's weird. It doesn't work. It never did, never will. Um, but when you see it as a field that moves with matter or causes matter and the whole 9 yards, it's all one thing, okay? And you recognize it in a big scale so where we can actually see what's going on and then bring it down to scale. So when we look at the LL tensor, which is literally just calculating angular momentum of two black holes, where they lose mass when they collide, right? But nothing comes out except for gravitational waves. But even before they collide, they're having gravitational waves come out, which is angular momentum. All right, that's what these gravitational waves. It's shock waves through the medium of the field. All right, it is shock waves through the field. It is unstretching. All right, the field itself. So gravity is a tensioning, and heat or expansion is the reverse twist, right? So as something tries to collapse, something else is trying to force it apart. So you got heat and compression, expansion and compression, right? And that's literally what they did is they calculated it as angular momentum, all right? So that when these things are rotating and they're losing momentum, but they're rotating faster, but they're losing momentum. That momentum is going out into the universe as shock waves of angular momentum, all right? But it's coming out now instead of going in, all right? Remember, this is a twist and counter twist. It's going out as angular momentum in a much wider range. And then when they collide, they have less mass because they released a whole bunch of that energy. All right? Energy is mass and mass is energy. All right? It's all the same thing. We're all part of the same field. All right? I got to work on the calculations. I'm not that good with that at that high level of math, but I'm going to work on it. I'm going to see what I can come up with. All right? Wish me luck.